Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Welcome to episode 70 of the Reliability Matters podcast. Today's episode is a little different from past ones. Normally, I don't get into specific products with my guests. Rather, we discuss best practices within a specific part of the electronic assembly process. I have another show where we discuss specific products within the electronic assembly space. That show is called Innovations in Technology. The debut episode, which debuted today, of Innovations in Technology, featured a conversation with the co-founder of a company which engineered a truly innovative, even disruptive technology, which I believe will eventually change the way we think about printed circuit board fabrication. So, today I stole the tapes from the other show's debut episode, and I'm featuring it as an episode on Reliability Matters. In fact, this episode. I'm confident you'll find this conversation fascinating. So, here's episode 70 of the Reliability Matters podcast, which is also episode 1 of the Innovations in Technology podcast. Enjoy. I'll see you soon. My guest today is Amit Dror, co-founder and customer success officer for Nano Dimension Limited. Amit served as Nano Dimension's chief executive officer from 2014 to 2019. Nano Dimension has produced a product which arguably can be described as a true disruptive force within the electronic assembly space. We're all experienced with inkjet printers. Inkjet nozzles travel from left to right, back and forth over a sheet of paper, and when the printing process has been completed, out shoots a sheet of paper with text or images deposited on the paper surface. Now imagine a different type of printer. Instead of 4-color ink cartridges, there are 2 basic inks, one a dielectric ink and the other a silver-based conductive ink. The print heads travel back and forth, and when the printing process is finished, out pops a multi-layer circuit board complete with vias, through holes, ground planes, and conductive traces, and even markings, ready for component placement and reflow. Need another board? Just press print again. This technology places a new meaning to printed circuit board. And this technology is available today. Nano Dimension has combined 3D printing and inkjet technology to produce the first ever circuit board printer capable of printing complex multi-layer boards at the push of a button without any human interaction. Talk about lights out manufacturing. We're going to talk about all of this great technology and where they see themselves in the future when I return in just a moment. Welcome back. Once again, I'm Mike Conrad, and it is my privilege and pleasure to welcome my guest today, Amit Dror. Thank you for being my guest from Nano Dimensions. Thank you for being here.
Thank you, Mike. Thank you for having me.
We are time shifting today. It's 10 p.m. California time. It's 8 a.m. Israel time. We're obviously on different continents, so thanks for agreeing to get up early. And I'm up late, and we'll make this work. So I wish all my guests could be geographically much closer, but that's the way it is. We're a big world, and thanks for time shifting with me. So I did, as any good host would do, if I am a good host, we do some background research, and I went on YouTube, one of my favorite channels for finding out what's going on with companies, and I was researching Nano Dimension, and about at least 90% of all, and there's a lot of material on your company out there. Most of it has to do with your stock. I guess many consider your company to have a hot stock, and we're not a stock program. I'm not smart enough to play that game, but you do trade on the NASDAQ under NNDM. So for those who do play that game, there's a lot of very interesting information out there about your stock, but we're not going to get into that. What we're going to get into is the technology behind your product. It's not often I get to interview somebody that has what I would consider a disruptive technology. I think that is arguably what you guys are making, a disruptive technology. And in our world, in the high-tech electronic assembly space, there's not a lot of revolution that's going on. It's mostly evolution. We're making basically the same products we've had since the 70s or 80s, just smaller, faster, cheaper, better, more accurate, things like that. Your product in this application, as far as I can tell, has never been done before, at least not that I can find. So I think it definitely qualifies as kind of a rare, in these days, revolutionary technology. So we want to get into that. But first, why don't you explain to my audience what Nano Dimensions is all about, and then we can get into the product that you make.
Great. So Nano Dimension has taken the dream of probably many of us, which is to 3D print different types of electronics. And that makes it revolutionary because our focus started with PCBs. The idea was, going back to day one, that pretty much every electronics engineer could upload a design file, make it a Gerber, Exelon, STL, and just be able to print it, in-house in his office in a way. And I'm referring, of course, to complex multi-layer PCBs. That's where it all started. And that started about 7 or maybe already 8 years ago. And today, what Nano Dimension is doing is pretty much executing on that dream, which is transforming the electronics manufacturing and hopefully the whole industry from the traditional classic making of PCBs and other components into something that adopts this disruptive technology of 3D printing.
Now, 3D printing, my view of 3D printing is very, very basic. And I've seen a few 3D printers that take quite a bit of time building layer upon layer upon layer of generally plastic type materials to form a widget of some sort, right? You've taken that to kind of the next level. So that when I look at printed circuit boards being fabricated, traditionally, they use laminate materials, usually like an FR4 or something like that. There's a lot of metal plating going on. There's a lot of pressure going on to squeeze these laminates together. There's a lot of components to it. It's kind of a dirty business.
Absolutely.
It's lots of chemicals and hazards and things like that. And you've changed that. Now, the problem, if I have a product that I'm going to make 10 of, or 1 of, or 2 of, then traditional circuit board fabrication becomes very expensive because the world has turned circuit boards into a commodity, basically. And everyone's talking about how many tens of thousands of boards they can make in X number of days, and usually in lands far, far away, where quality is a little out of reach. Quality control might be a little bit out of reach. And I know, at least in North America, while there are board fab shops still here in North America, the overwhelming majority are in Asia, mostly China and some other places where the labor rates are much lower. And that poses a problem. I own a manufacturing company. We build equipment for the electronic assembly industry. And we sell, 200 or 300 machines a year. And, getting boards made is always a dilemma, because it's cheaper to get more made than you need and throw the rest away than it is to, find like a proto shop to make small quantities. So, and our technology changes, so our boards go obsolete before we can even use up the supply. So I'm assuming that printing a board may be, on one hand, a little slower. If you wanted to print 1,000 versus getting 1,000 fabricated traditionally, but tell me what some of the advantages are with 3D printing a circuit board, compared to the traditional methods of doing it.
So first, I'd like to comment on what you just mentioned. And I think it's very important to acknowledge that manufacturing independence is a key element that any company needs to take into consideration. The world is changing, and the independence is not just about commodities. the world is moving into more sophisticated, more customized solutions. Just by looking, just throw some examples into the air. If we think about all those smart cars, smart houses, smart devices, then sure, we could get an Apple or a Samsung, but what about all those new innovative companies that try to enter the market, and they want to enter the market with 1,000 pieces or 5,000 pieces? They have a dilemma. They don't know how to enter the market. And we believe that by using advanced technology that offer this new approach of high mix, low volume at a fair price, we could make a change. So that's just in principle about how we foresee the changes in the market. And Mike, we're not the only one, because the whole concept of Industry 4.0, and in principle, the whole concept of, there are different names to it, but say distributed manufacturing. Let's make sure that we have the capacity and the capabilities required in order to manufacture sophisticated devices close to the customer. That is something that is being promoted and pushed throughout all the advanced, say, Western countries, whether it's the US, Germany, and others. So that's just in comment to what you said before. Now, referring to the other point you mentioned about the different materials and the different steps that we're all familiar with, then yeah, when you think of a factory, you have FR4, you have copper, you have all those chemicals that are being normally washed. Say, if that would be in some foreign country, it could be that these materials would actually be washed into the rivers, right? And drilling and plating, and I can go on and on because there's so many steps to get things sophisticated. So with that in mind, I'd like to say a few words about how does our technology works. The whole concept of 3D printing or additive manufacturing is based on putting one layer on top of the other. And what Nano Dimension did was to find out which are those unique materials that can supply the properties that could help companies create devices, whether you would like to call them PCBs, we call them HiPads, high performance electronic devices, because they're not identical to PCB. They actually have some differences and some advantages. For example, our Dragonfly system, which is out there in the market with many US customers, can print conductive ink, which is based on silver, and a dielectric material, which is, parallel to FR4, has very similar properties. And we know how to process these materials in a very accurate manner, something that goes to an accuracy of traces of about 3 or 3.5 mil, right? 75 microns. And with that level of resolution, we could actually support creation of PCBs and other devices to a level of 3 millimeters, and sometimes even up to 50 different layers, if that would be a normal PCB. Now, to the comment of drilling and holes and plating, think about it, Mike. You don't have to pay for the holes because we just don't print them. So, we're building up the holes as we print the surface.
Yeah, before I want to dive into the advantages of not drilling, because that actually, I'm in the cleaning business, and we have a phenomenon called, conductive anodic filament, which is a result of drilling damage that creates these little micro cracks that the plating solutions, another thing you probably don't need, gets in there, and we form basically dendritic growth between the layers of the board, which creates parasitic leakage or outright short. So before we go down that hole, so to speak, let me just back up a little bit. Your technology actually prints an entire circuit board, for lack of a better name for it, including the dielectric material and the conductive material. So you're basically printing the substrate, and you're printing the traces that go within the layers of that substrate and on the surface of that substrate. That's correct?
That is absolutely correct.
Okay, so in the world of traditional boards, we'd use a laminate, an FR4 or something similar. What is the material, the hard material that would be the equivalent of the laminate that you're printing with, and is that an ink over ink over ink over ink over ink to give it rigidity and structure, or is it some kind of plastic material like you would see in traditional 3D printing? Tell me how that process works.
So that material would be ink, which we've developed, and it's like an acrylate polymer that was developed with the purpose to answer two needs. One, of course, the dielectric properties required. Secondly, to withstand the thermal properties required, because later on, that board would need to go onto soldering or some kind of oven, right, to do the soldering. So it can't really be just a standard plastic, for that matter, that would melt. And we've developed that material, as well as the other material, which is the conductive nano silver based ink. Also a very unique material that we're using, while both material within the printer are kept as liquid, basically inks, and are printed. Okay, at the moment we're using inkjet technology, and we are considering to expand on more technologies as we look forward. But inkjet technology at the moment enables us to print these two very different materials almost simultaneously. One drop falls next to the other, and the printer, the system, knows how to cure them in order to get them solid, as well as to sinter, the sintering process of the nano silver parts, in order to melt them and to create a full solid trace.
The whole term inks just confuses me, because when I think of ink, I think of not a structural material. I think of a very thin material that sits on top of some other material, performs a contrast, and then you can read something. That's how I think of ink. In order to get a rigid surface, the board itself, the dielectric board itself, how many layers of ink are required to form, a traditional, I don't know, at 62, whatever it is, thickness board? Is that thousands of layers? Is it hundreds of layers? What's involved?
So that is an excellent question, an excellent point. Think of silver. It would be pretty difficult to use a filament. We're actually building up the nano silver particles from scratch. We're building them from a molecule level, and we keep them extremely small. And to answer your question, we end up with thousands of layers. So that process takes hours to build a board. Having said that, looking into the future, the print area grows. So the good thing with much of the printing technology is that you could relatively easily scale it up, and you could put multiple print heads, one next to the other, in order to increase the throughput. Yep.
And how many print heads in your Dragonfly system, for example? How many print heads are traditionally part of that system?
Yeah, well, it's funny to use the term traditionally when something is so innovative.
Well,
but
that's true. There's nothing traditional about your product. So in a production system that you sell to a customer, how many print heads?
Here's the thing: with the Dragonfly, there are two print heads, but each one has several hundreds of nozzles. So differently to a dispenser-based printer of any kind, when using inkjet technology, then one head actually includes hundreds of separate tiny nozzles. Each one can jet accurately at a very different positions because the printhead moves through the printing, right? The axes are moving. So at the moment, the Dragonfly has 2 printheads, each one with several hundreds of nozzles. Okay, that makes it multiple, jetting at the same time. And looking into the future, we actually are working on increasing that and having multiple printheads, and that would make it thousands of nozzles for each one of the materials.
And that will obviously speed up the entire process.
Correct. So that's a very important point. The innovation and the achievements we've made with the call it entry-level product, which is the Dragonfly family. Well, we had to go through some hurdles in order to overcome challenges, but from that moment and on, at least some aspects of our coming development are more on the engineering side, because inkjet technology is well used on the more common printing industry, where they just print different colors and paint for other purposes. That is more of an engineering challenge that we feel very comfortable with, the scaling up of the system. The more interesting part of our development is always on the innovation side. How do we develop more materials, better materials? How do we end up with a system in principle that can do more than printing? For example, the Dragonfly can print multi-layer PCB. Okay, it can also print, by the way, other elements which are traditionally more difficult to create. For example, we could print as part of the PCB an RF antenna or a coil, and we could even print, for that matter, a coil which is on the 3D level, like a cone of a coil. And we're doing things like that. Our customers are doing things like that. That makes it much more than a PCB. Okay?
Right.
Next challenge would be, okay, at the moment, you create that unique device, but when it comes to solder the other components, whatever chip or other element you need to connect, at the moment, it could either be done manually, or you could use a soldering reflow oven by basically placing the components, put it in the reflow oven. But what if you could have the whole process done on the same line? Say, having a robotic arm that is doing the pick and place for you. That would definitely improve the yield, because you take one printed part and you move it to a different system, or you handle things manually. Obviously, it's possible. We're all doing it, but when we look into the future, we foresee something that is more, how should I put it, more autonomous. Think of a company, maybe like yours, that requires to have a few hundreds of pieces, but you also need to make sure that you reach the level of course, quality, right? And to do that, you would feel more comfortable having a system that is doing all different steps at once, or one after the other, rather than having a manual involvement of a technician or an engineer. And this is where we're going. We're going into the world of kind of autonomous systems, maybe not 100%, and definitely by implementing integration of additional technologies that go beyond printing. But we're definitely in the process of getting the world of electronics manufacturing something that is even more complete.
Yeah, you refer to the machine as lights out manufacturing. I hear that term all the time, and I actually haven't really come across anything that's truly lights out at this point. But this definitely is very close to that, if not hitting that mark. How much user intervention is required once someone pushes the print button, and do they just walk away and come back hours or days later, or how much is an operator required to monitor the process, or is it truly at least that portion of the fabrication process lights out?
So I think that was the key for us to use this, LDM, or lights out digital manufacturing, because obviously the first product that came out really required babysitting day and night, and it became clear to us by our customers saying, we love the technology, but it really takes too much effort just being there and maybe wiping the print heads every few hours, and maybe checking things every few days, and we don't get to benefit the weekends, because people don't want to stay around the machine on the weekend. They want to go out fishing. And what we did, moving from the previous Dragonfly, the first version, to the LDM, was to create all the relevant subsystems that are actually doing these things automatically, whether it's the cleaning of the printheads, washing them automatically, whether it's monitoring more effectively, and altogether increasing the quality. And what I'm trying to say here, other than answering your question, is that I want to give credit to some of our competitors, because there are other companies out there that are also doing AME technology, additively manufacturing electronics. Some of them are using different technologies, and this is an exciting world. I mean, there is no doubt the world of electronics manufacturing is evolving, just like the rest of manufacturing world all over. The difference with Nano Dimension is that what we had in mind on day one was not just the tech innovation. And we said this company, at least we hoped, we said, we hope that this company is not going to be just about innovative projects and proving of technology. The vision, the horizon we had in mind is that we want to actually lead changes in how electronics is made. And it did take quite a few years. I mean, we've been around for 7, almost 8 years, but now we're actually starting to see that happening, because seeing those devices and reaching the level of quality, repeatability, and I hope you're going to ask me a few more questions about other things we're doing soon. But it's really exciting for me as a co-founder that was there on day one, and hey, we were pretty naive back then. We said every engineer should just have a printer. What's the big deal? Just have one.
Right.
It's
just
that
get
simple. Huh?
Yeah, exactly. What were some of the differences between the original Dragonfly and the one you're producing today?
Fairly, I should say, quality. Just it's a different ball game. And second thing is the understanding that it's not just about PCB. Our whole industry is based on the fact that today, right, that in order to connect a few parts together, you got to have a board. It could be a small one, could be a simple one, but I mean, we're not going to take a PCB and a memory chip and we're just going to wire them one to the other, right? We're always going to have, no matter what, a board. But here's the thing, Mike. The whole concept of printed circuit boards, which are flat. I mean, hey, I say PCB, you say PCB. We imagine the same thing, right? It's that flat square with pretty straight lines, sharp angles in the corner of those traces, right? And that would be a bare board. And then thinking of a populated board, we would also imagine a few chips, right, soldered on top of that PCB. Now, honestly, Mike, this is just because of limitations. If I said there is no PCB, it's for us to invent how we want things to be, it would look different, right? I'll give you a very simple example. A mouse that you're using, say that you're using your computer and you have a mouse. Well, it would be rounded, right? Ergonomically set for your hand. But you know, and I know, if you open that device,
Boards are
what would we
flat.
see inside it?
Yes.
Flat, right? That doesn't make any sense. That's not effective. That's not efficient. And that's a very simple example. Things are flat because today the effective way to produce a multi-layer circuit would be using PCB. And we have learned, and we've learned that from our customer, that the biggest advantage of Nano Dimension solution at the moment is not about PCB. I mean, you could get a PCB. I mean, sure, you'd rather have it next door, but hey, you could get it for effective cost. And you know what? You would probably get a better quality PCB from a $500 million factory than you would from a $500,000 system, right? Still. But what you would find pretty hard to get from a PCB factory is a unique device. And let me invent something on the fly, okay? Something that is shaped like half a ball, or maybe like an Eiffel Tower, that has the components not soldered on top. No, they're just like a multi-chip module. They're just like packed inside that device that you've created. And you know, you're not gonna have the pads just on top of that device. You're gonna have pads all over, on the sides. You're gonna have them on different angles, and and that device of yours, Mike, would really be effective because you're not gonna be limited to straight lines. So maybe just connecting one corner to the other would become more effective for you if that trace, so to speak, would go diagonally, but not even straight. It would go like in a loop from one corner to the other, because you're also going to have a printed antenna within that device, and you would want to make sure that there is no noise or other elements, magnetic influences on that antenna. So is that science fiction? Well, Mike, no, it's not. We're doing things like that. You could take today a design of this hybrid creature I just invented, which could, no, I mean, you could also make that obviously in more traditional method. It would only take you multiple steps, right? You will create a simple PCB, and you will have someone creating for you, maybe with a mold, I don't know, maybe with other methods, this shape, and you will be able to get the shape of antenna that you wanted. And in a good assembly house that has specialty capabilities would figure out how to stitch all these different elements together for you. You can have that. You know what? Some of our defense customers are doing things like that, and they did things like that before we came along. But what if you could, take designs of a CAD design and an ECAD, a Gerber file, and what if you could merge those designs together on the design level, Mike? Okay? And maybe even have the element of, call it MCAD with the elements, print that, and now I'm looking a little bit into the future, because there are some things we still cannot do. But within that creation and this printing of that device, you embed the components and continue the printing moving forward. Okay?
Sure. Something that you could never do in a traditional fab shop.
Outside of the pick and place part, we're doing good things now.
Yeah, that's fascinating. What can't be done with it? Well, first of all, let me back up a little bit. I think the term printed circuit board applies way more to your technology than the way traditionally boards are made, because there's the word printed. I don't know where printed comes from, because it's really etching and and all plating and all that. Printed circuit board. I mean, you guys took that term literally, and you are literally printing a circuit board. So I think the PCB acronym applies more to your product than traditional, but the traditional people grabbed it first. So yeah,
Exactly.
they have it. So when people think of printed circuit board, there's nothing printing about it. But what are some of the things that your technology, your Dragonfly system, cannot do that a more traditional form of printed circuit board fabricators can do? Are there any limitations right now?
So at the moment, there are limitations. For example, throughput. There is no way a device like ours could compete with the speed of proper PCB manufacturing. Other aspects refer to, let me think of things that are crucial. Well, the price, Mike. At the moment, we're using for the conductive material silver. And the reason we're using silver is that when you go to nanoparticles, in order to maintain the material the way that you want, especially when you print them and you sinter them, still copper is not there yet. I mean, it's getting there, but it's not there yet. And unfortunately, silver is, I think, like 100 times and maybe even more expensive comparing to copper. So our devices, if you think of simple boards, would always be more expensive. The materials are more expensive. Well, luckily, the cost in the world of PCBs is not based just on the cost of materials. It's highly based on setup cost and other elements. So we can give a fight when it comes to high mix, very low volume at the moment. But, well, that's a big limitation, right? Because in principle, the technology should apply to more. But in order to do that, we are required to improve our materials and step into additional materials which are at a lower cost, improve our throughput, which is obviously nothing nearby existing technologies. So I guess these are the most these are the key differences where the traditional technology has at the moment big advantages.
Right.
But we will get there.
Well, any brand new technology, particularly a disruptive force technology, generally starts off more expensive and then works its way down as it scales and as evolution within that revolutionary product takes place. It sounds like throughput can be remedied by the next gen and next gen and next gen machine with more and more and more nozzles, right? Then you can print faster. I would imagine you guys are probably hard working on a way to print copper or a cheaper conductive material other than silver. Is that possible, or is it just not there yet?
It is possible, and some level of proof of concept was done successfully, but it's not there yet in the meaning of the quality, the repeatability, the conductivity that you get at the moment. Having said that, at the moment, we focus on more of the high-end solutions needed in the market. And surprisingly, we see more and more of those. I'll give you a few examples. The need for, system in package or multi-chip models, you see quite a lot of solutions in the market, or products for that matter, that turn to silicon. They actually use different types of silicon manufacturing in order to come with an effective, the part. And that, the setup cost of having something in the semis industry done for you. So it's a high barrier. And we believe that these are areas where, to begin with, we could offer this advantage of better cost, simply better cost. High mix, low volume, um, pretty fast and low cost. So that, and what else? What else? Well, we have some barriers. I mentioned, for example, the fact we don't do yet pick and place. That is a big deal. That is a big deal. And I would like to throw in another thing that we have just stepped into. At Nano Dimension, we highly and really strongly believe in artificial intelligence. So something we've just done recently, we acquired the technology. We acquired a company, DeepQ, but it's really about their technology of deep learning. We believe that improving the effectiveness of different steps on creating a solution is crucial in order to move forward, whether it's with simple review of the print in real time and just being able to predict, is it going to succeed or not, or what should I change in real time on that printer in order to make sure I improve my yield and I even get a better result than before. So that would be basic thing to do with the deep learning, artificial intelligence.
So is
But it goes
AI
over.
is AI incorporate? Well, if you incorporate AI into your Dragonfly system, for example, right now your Dragonfly system takes a Gerber file or something similar and figures out the
Print.
specific roadmap to what layers to print and what direction to print. Based on probably very common inkjet technology. It knows how to do it. How give me an example of how AI can improve that process, since you're only printing what you're getting, right? You're getting a Gerber file or something similar and you're printing that. How does AI can AI change the circuitry design a little bit to make it more efficient to print, or where's the payoff with AI within
So
your system?
there are two areas. There are two areas, and I'll point them out. One could be on the design level. So that would probably happen prior to starting the print. You could optimize a design by being able to analyze it and realize that tiny changes which do not even affect the design, but may change how you jet the different droplets, creating the voxels for that matter, could optimize the print. So on the design level is one. The other one is in the real time of printing. I'll give you an example. Let's say that we recommend a range of temperatures and humidity and call it environmental aspects to our customers. And let's say that some customers, for whichever reason, have a defect in their environment, and there is a gradual change within a print. I'm just inventing something, right? Those changes could affect the print. Maybe if the temperature changes, then a certain aspect of the curing should be done slightly differently. Maybe I want to add a few seconds to a certain step. Now, you could not manage that in real time unless somebody who's a real expert is monitoring the system in real time. But that doesn't make sense. Surely we could monitor all these things, but the decisions, when you think about AI, taking the right decisions in real time is something that that could be done, and we believe will be done, and would expedite our journey into the mainstream of manufacturing.
Excellent. I'm bouncing around a little bit. I guess one of the interesting things about your technology is so many what would be separate processes, all performed by a board fabricator, are all done in one box. So you're printing the board material. Basically, you're printing the conductive traces. You're basically printing solder masks
vias.
because the vias,
The solder mask, the hole drilling. Well, you don't drill the hole, right? You create them. Plating, well, it's part of the print. You want to have full via, you got it. Buried via, you got it. As you said, solder mask, Sure, you just print another
You
layer
just
on top.
overprint, right? You just overprint for solder masks,
Annotation,
basically.
you got it.
Okay, tell me about board markings. Are you printing board markings with silver ink just because it's already loaded in the system, or are you using just regular, white colored ink for board markings?
At the moment, it's the first option. We just use the silver because it's in
It's already
there.
there, right?
It could be that in the future, let's say that looking into in the future where our systems are really the heart of manufacturing, and you want to save every cent. Well, maybe by then we're gonna have another printhead that has a low cost, simple ink, just to reduce cost, maybe.
Right.
But it's not really that expensive to have one layer of silver at the
Sure.
moment.
It doesn't have to conduct, lots of amps,
Exactly.
and all that stuff. I saw an interview with your CEO. It was one of those stock price interviews, so it was a financial channel of some sort. And he was saying, during the pandemic, a lot of capital budgets were frozen, and your products are not inexpensive. Necessity being the mother of invention, this came out, Nanos. Tell me about what Nanos is all about.
Okay, so let's say that you and I talk, and you have this amazing design, something extremely unique that you would not even consider doing in conventional, traditional way. Okay, and you learn that Nano Dimensions AME technology could actually do that for you, but you're not in position, or not, don't have the will to spend hundreds of thousands of dollars to buy a system. But still, you would love to give it a try, right? And if that would cost you whatever, $3,000, you would say, you know what, I really want to have it. Then this is what Nanos is for. Just give us a call, and we get one of our application engineers on the call with you, and you guys get to discuss that design of yours and how to optimize it, and then we just print it for you. Nano stands for Nano Dimension Services, like a service bureau of all the things you wanted to do, but you just couldn't.
Right. Now that makes a lot of sense. I think one of the advantages to produce a board in-house is, I'm a big believer in, it's a bit Pollyannish, but I'm a big believer in, buy and build where you sell, right? We try and source all of our products from North America when it's not always possible, but the majority of our products are sourced locally. We actually pay more to buy locally because we just believe in, creating an economy, in the world we live in, right? Buy next door. If you can't buy next door, buy the next state. If you can't buy the next state, buy the next country, but start locally, and then work yourself out. But I think in your case, besides that, there is also a great advantage strategically, because I can see a lot of military type, or highly proprietary, sensitive technology that is always problematic when they source out, the board to be made. There's non-disclosures that have to be signed, and there's always concern, particularly with some of the countries that are known to produce the majority of the boards, with intellectual property theft and all of that. So I would imagine all that is remedied if they can produce the board behind closed doors within their own facility. Then the concern about IP theft and other things along those same lines are eliminated because they're all done in-house. Besides the advantage of low quantity production, or high mix, low volume production, there's also an inherent amount of security involved with having that all done, in one black box, behind closed doors. Was that part of the motivation as well? And are you seeing customers like that gravitate toward this technology for that reason?
Yes, the answer is absolutely yes. And many of our customers are defense-related entities, and they're pretty relieved with having something that enables them to design, iterate real fast in-house, and come up with their. I mean, normally in those cases of defense customers, it's high mix, low volume. That's what these guys are doing, and we see we see that on ourselves. We see that on ourselves, and especially in the U.S., which is our primary market. I think that probably one of the reasons why we moved our headquarters to Florida, and in our largest growth in manpower and activity is in the US, is also related to that. However, I would like to point out the previous point you mentioned. There is one thing about supporting the economy which is really important, I guess for every country. But there is another thing, which the ecological point of view. Having things done in-house means you don't have to ship them over a plane or a ship, and you really support the environment on one hand. Then the fact that you're using additive manufacturing that only uses the part that you need, rather than taking big FR4 a piece and start carving it, and then putting that into all those different chemicals. That is another aspect. So I think with the world getting greener, and all of us want to have a clean and more better place to live in, the whole concept of AME, additively manufactured electronics, aligns very nicely. So in a way, it comes together. Keep it in-house, keep it clean, keep it confidential.
Yeah, that makes a lot of sense. I think that, arguably the carbon footprint on building boards inside one box within the facility that's going to use those boards is certainly much, much smaller than buying a few hundred boards, putting them on an airplane, and bringing them in. Not to mention the shipping costs involved too. What caused you? Well, before I ask that, you take Gerber files. Do those Gerber files have to be modified in any special way versus the types of files they would send?
We just take a standard Gerber file, but obviously they have to fit in within our design rules. So at the moment, we don't go lower than 75 microns on the trace, and our vias, if I'm not mistaken, it's vias of 250 or 300. I'm not sure, but my point is,
design rules.
You have to work within the design rules, but the Gerber file in terms of format is just a standard one.
Mm-hmm.
And actually we go beyond that, because it's not just the Gerber file, it's excellent files, it's STL files, other formats of 3D which are not even common within the electronics industry, because as said before, we are a free form, free design, so we're pretty agnostic to that, and we can support probably most design files today.
Yeah, excellent. So one day y'all woke up and said, we want to create this new technology. What was the genesis of that? What caused you to take something that has been so commoditized that very few people are complaining about, the traditional way to get a circuit board? At least they've given up complaining about it, I suppose. What made you have the desire to shake up that paradigm, and what was the genesis of all this?
Okay, so that takes me back probably 7 or 8 years ago now. I love technology, and I'm sure that you might love technology. So you probably also remember how back in 2013, say, you could see 3D printing, not for electronics, just 3D printing everywhere. It was all over the place. We're like, oh my God, 3D printing is going to make my coffee in the morning. I don't know. It was all about 3D printing. And we were really,
if you could build a 3D printer that makes coffee, that would be a whole nother interview.
I'd like to make sure someone's doing a very good quality assurance before I get that printer. But you do see, today you see printers that print, meat, right? You see things which are pretty crazy, right? It goes into biology. But again, 8 years ago, everyone's talking about how 3D printers are gonna manufacture everything, and it was really fascinating. And the other co-founders, we were 4 well, younger than we are today, at least,
Aren't we all?
entrepreneurs, and we were thinking of, what can we do in that world of 3D printing? And there is always the feeling that everything was already invented. Like, oh, what can we? Oh, they do this, they do that. This is smaller, this is bigger. And the person that was the first CTO of the company said, I think the time has come to take some advanced technologies and actually 3D print a PCB. He said he had the right background. He knew a lot about inkjet and also about nanomaterials. And he said, well, you know what? I strongly believe that if we get the right, initially we had to license some patents, right, related to materials, and we take that technology. If we integrate it right, then every electronics engineer could actually print his own boards in-house. And we were like, wow, this is great. Let's do it.
And what were some of the obstacles you didn't foresee that banged you over the head one day? What?
Well, I don't know if you can see the white hair that I have now, but I have quite a bit.
Yes.
First of all, electronics manufacturing is not mechanical parts manufacturing. It's not just about the shape and size. And it was very naive of us to think that it could be in any office. That doesn't work. You have to make sure that through the printing process, the environmental conditions are met, at least within reasonable ranges. You have to think about how you keep the environment clean. I mean, obviously we have all the right standards today, and you could stand next to the machine and breathe, but what do you do with the materials that have to be filtered? So that makes it more complex. We didn't think of that on day one. The cost. When you think of a printer that goes onto a desktop of a person, say, that would be what? A 50K top? How much money would you invest into something that goes on a desktop? And now it's very clear this is a serious manufacturing machine, right? You could add, another zero at the initial price we had in mind today. So, we're thinking almost, I wouldn't say consumer, but definitely professional every desk PCB. And today we're talking about very high mix. It's much more than a PCB, right? We're talking RF, we're talking multi-chip packaging, we're talking things like that, and a manufacturing system, and we're talking AI in order to take next step and really start marching towards mainstream of electronics manufacturing.
Right. You
So
talked about
it's a big difference, and I'm not sure if it's clear enough, but the hurdles were horrible. Chemistry, materials that didn't play nice and did what they wanted, and
right.
coming up with a board. Just think of a board where the conductivity is totally different in every area of the board. What do you do? I mean, like, why?
Right.
But we're not there now.
You didn't pick an easy first go.
Hey, if I didn't know the water was so deep, maybe I wouldn't have jumped. So
I host another show on entrepreneurship within the EMS space, and I think naivety is any entrepreneur's best friend, right? Because if we knew all the risks, if we knew all of the challenges, we would just choose not to do it. Like you said, if you knew the water was cold and deep, you wouldn't have jumped into it. So there is something to say about what we don't know kind of allows us to take that big leap in there. What does the future hold? You talked about the machine with 1,000 nozzles. I can see that scale. Any other plans that you can talk about without having to kill me and my audience that you see your company going toward?
So the important thing is about end-to-end solution. Some of our challenges today on our go-to-market is that with respect to the amazing things our system offers, it's not enough. If you really want to manufacture a fully populated, tested working board in-house, it's not just about the PCB, right? You gotta have additional elements. So the near future is really about making sure that the end-to-end solution you need would actually be received by us. Because sure, high mix, low volume, but it's going to be better in the near future. And then looking a little bit farther down the road, it's about scaling farther throughput, and also increasing the range of materials, because that can really, I mean, it's a whole session thinking of what different materials, let me just say flexible materials or support materials that can really help you create a 3D which has large spaces, empty spaces within a board. Think of all the things that could be achieved with that. Okay, so near future, making sure the end-to-end solution you're getting is more complete, scaling up, and in parallel more materials.
I would think also, because this just happens with any technology as it matures and as there's competition, is the price starts dropping down as scalability rises. Is there a desire to in the future have, I'm just throwing a number out just for discussion's sake, have $20,000 benchtop machines that can do this, or do you think this will always be a premium priced product? Do you see the ability to bring it to the masses, or is there a strategic advantage to knowing basically high rent customers that see the advantage in this?
I think it's fair to say that every technology starts with something that is unique, expensive, early adopters with specific needs.
They
right?
It.
I mean,
Yeah.
hey, we have a part that we created for L3 Harris up there on the space station, the International Space Station. So it starts with that, and you could compare that to the first computers.
Absolutely.
Right?
Yep.
Who was that smart guy that said the world would need just 5 large?
I think Bill. Oh yeah. Well, I remember Bill Gates said, or at least he's quoted as saying, "I can't see a scenario where anyone would ever need more than 640K of RAM." Right.
Yeah. But my point is that at the moment, the near horizon is not that near anyway, but the horizon is, let's perfect it and make sure that it goes into the mainstream. Then from the mainstream, we will see how it starts coming down, and I'm sure it will go into the consumer level, but the process is probably, as I foresee it, is going to be very similar to the progression of others innovative technologies.
Sure.
I mean, I hold in my hand, you don't see it, but I hold my iPhone here. Okay, that is an amazing supercomputer.
Absolutely.
Amazing, right?
Yep.
There you go.
Yeah, and absolutely. Good point. I would think that if this technology becomes more mainstream, which it no doubt will, the cat's out of the bag, that'll happen. The world of IoT, the world of Internet of Things, is perfect you're perfect for IoT. Particularly going back to your comment about being able to custom shape a printed circuit board. Like, why do all boards have to be this thick and completely flat? IoT is, I always say IoT is the business of putting electronics in things that never had it before and probably don't need it, but we do it because we can do it. But we can do it better if we can design the electronics around the package as opposed to design the package around the electronics, which we do now. So I think that your technology has a lot of value in so many ways, as we've already discussed, but particularly in the way these boards can be packaged. The designer is no longer limited to a flat surface, and
Yes.
Who says it has to
There are
be flat?
specific
It's an old rule.
industries. Sorry, please.
No, I'm just saying that's an old rule. You've made that
Yeah.
flat rule obsolete. It doesn't have to be flat anymore.
Yeah, I'd like to share a couple of examples of industries that traditionally we would not even think about. I mean, sure, when you speak about IoT, it's easy because that's kind of all new. But what about the automotive industry? Cars, that was a very clear platform with a motor and engine, right? But today, look at Tesla, look at others. It's just they try to keep the platform as flat as possible, but then everything on top of it is curved and it's all electronics, communication systems, electronics, sensors, right? What is a car now? Even the battery, just control the battery. This is like it's a monster of every electronic advanced element you could imagine, and they gotta keep it um, looking good. And they gotta
Right.
make sure they miniaturize a lot of it. Okay. I don't need to speak of defense. That goes without saying that those guys have that. But let's talk about drones. I mean, hey, we wouldn't be speaking about drones 15 years ago. That was this science fiction thing. But drones are everywhere. Tiny ones, huge ones. Whether it's, speaking of carry on of humans in your future, or just those Amazon drones that would pick up your
Yep.
mail, whatever, and send it over to you. Drones, they need to be light. They need to be effective. Again, I'm giving examples for where AME technology could really fit and help verticals of industries to make leaps forward. If you compare what you could do with our technology on drones and how you would implement the same things with traditional technology, for example.
Yeah.
The medical devices. Okay, I can go for.
Oh no, medical devices. That's perfect. I mean, yeah, particularly these ingestible medical devices with cameras built in. I mean, you don't want a big flat circuit board, going down your throat, and worse
No, you
yet,
gotta keep them
coming out.
tiny.
Right.
Yeah.
That makes a lot of sense. As we wrap up, there is one question that has absolutely nothing to do with Nano Dimension. But in looking at your bio, you're kind of a serial entrepreneur. This is not your first rodeo. And one of the companies that you founded just stood out, and I have to ask you about that. Milk and Honey Distillery. What's that about?
Well, okay. So the credit goes to another co-founder of Nano Dimension, Simon Fried, friend of mine, and he actually came up with an idea just before we founded Nano Dimension. He said, we live in Israel, and there is not even one proper whiskey distillery. And I said, well, Simon, there isn't proper whiskey distilleries pretty much anywhere aside of, I don't know, Scotland, Ireland, the US.
There you go.
You don't
Yes,
get them.
sure.
And he said, it's about time to have one in Israel. And we hooked up with another co-founder of the Milk and Honey Distillery. And we just decided we're going to have something we could all be proud of, which is a proper, real whiskey distillery. And we did. We just said we're going to do it. Today, it produces more than 250,000 bottles. It actually wins a lot of prizes. Just won quite a few awards in recent few months. And we are exporting it to, I guess, 24 countries.
That's
Obviously,
amazing.
US is a major market. So you should give it a try.
I will
My
look for it.
subjective opinion that it's pretty good, but hey.
I will definitely look for it. You don't pick easy projects, do you? You don't pick projects with immediate returns. You can't just open a distillery and sell a bottle of whiskey in a day. There's things like aging and things like that, right? So
I think the key thing in life is do things you're passionate about rather
that's
than
true.
shortcuts, because we all need to bring on a salary to live, but if we're not happy with what we're doing, it's pretty difficult. I mean, so as long as you're passionate about it, you do it. And I'm pretty passionate about whiskey, and also about transformative technologies. So
Yeah, well, that
I see
clearly
how it's
shows.
linked.
So clearly, a bottle of milk and honey whiskey is included with every Dragonfly system, right?
Well, now that you mention it, I guess it is.
Now it is. You heard it here first. Heard it here first. Amit, thank you so much for being my guest today. I really appreciate it. Your technology is fascinating. As I said earlier, it's not often I get to talk to someone so early in the revolutionary stage of a product. And being part of this industry, I can certainly see a lot of benefits for this product. And I'm going to keep an eye on you guys and watch as the technology evolves, as the scale increases, and as the potential customer base continues to broaden beyond what arguably was probably a few people who could afford it and could benefit from it, to a much wider, more mainstream base. And maybe when the last fab shop somewhere in Asia shuts down, I'll remember this conversation, and this is the beginning of that disruptive technology. So thanks for being my guest today. I wish you and your team all, I don't think I need to wish you luck. I think you've already demonstrated that, but I wish you all the success in the world.
Thank you, Mike. Thank you very much.
Thanks for listening or watching the Reliability Matters podcast. Be sure to subscribe to the podcast on your favorite podcast app, such as Apple Podcasts, Google Podcasts, Spotify, and so many more. Also, be sure to check out my other podcasts, including the Concept to Creation podcast, where I feature conversations with entrepreneurs within the electronic assembly space, and, as we discussed earlier at the beginning of this show, the Innovations in Technology podcast, where we discuss innovative products within our industry. All three shows are also available in video format. Check out the Reliability Matters or Concept to Creation or Innovations in Technology podcasts on YouTube. Just search the show's name and you can find all three shows. Or go to MikeConrad.com. That's Conrad with a K. All three shows also appear there. Again, thanks for being part of my podcast family. I appreciate you being here. Until next time, stay safe, stay healthy, and stay happy. And of course, keep doing it right. See you again soon.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.